Okay, this is quiz 2. First problem says that you're supposed to graph all four of those functions on the same axes. So here's some big axes for, whoa, if I could draw a straight line, I'd be dangerous. Okay, that's pretty bad. Let's see if I can do better than that. That's a little better. Okay, so I need e to the x, and e to the x is the exponential function that's asymptotic on the left and grows exponentially this way. So this is e to the x. And e to the minus x is just the reflection of that through the y-axis. So as x gets large, we're decreasing, and we go through the same point, 0, 1, and then we become asymptotic on the right. So this is e to the minus x. And then the other two functions are 8 to the x and 8 to the minus x. Well, 8 is bigger than e. E is about 2.7. 8 is going to grow really fast coming out of here. So it's going to go up like that. So this is 8 to the x, and it's going to go down very fast relative to e to the x. And 8 to the minus x is just the reverse, the flip of that, going through the y-axis. So that's your 8 to the minus x. Okay, and that's number 1. Number 2 says find a formula for the inverse of log of x plus 3. So I want y equals log of x plus 3 log of x plus 3. And to get the inverse of that, we reverse the roles of x and y. So x equals log of y plus 3, and then we have to solve for y, and that will be the inverse. So how do we get rid of this pesky log? Well, we have to exponentiate both sides. So we take e to that, and we've got to get the same as e to that. So we're going to have e to the x equals, and the reason for doing that is that e and exponential, e and the log functions are inverses of each other, and so they cancel. So you're left with this. Finally, subtract 3 from both sides, so y equals e to the x minus 3. And that will be our inverse function, f inverse of x, if this function was our f of x to begin with. Okay, that's number 2. And then number 3 is to find the exact value of 3 things. The log of 1 over e. There's a bunch of ways to do this one. Maybe the easiest way, I don't know. The easiest way is log of e to the minus 1, and then realize that the log and the exponential function are inverses of each other, so they kill each other, leaving you with minus 1. You could also do the log of 1 minus the log of e, and know that the log of 1 is 0, and the log of e is 1, and so you get minus 1. Same thing. There's other ways to do this as well. Second problem is log base 10 of the square root of 10. And if you put this in exponential form, you probably will see it right away. This is 10 to the 1/2 power. And you're taking the log of that. So the log base 10 and the 10 to a power are inverses of each other, so the answer is 1/2. You could pull the 1/2 down, 1/2 log 10 of 10, and then you'd have to recognize that log 10 of 10 is 1. Same thing. But you can tell right away from here, because log base 10 and the exponential function base 10 are inverses of each other. Finally, e to the power minus 2 log 5. This natural log of 5. Okay, here you've got to bring that minus 2 inside the log so that you can cancel your e and your natural log. So this is going to be e to the power natural log of 5 to the negative 2. So you have to know the laws of exponents backwards and forwards, because the laws of exponents allow you to pull this exponent out of the log as a multiplier, Or conversely, if you've got a multiplier on the outside of the log, you can push it in as an exponent of that argument of log. So now you've got e and log canceling each other, so you're left with 5 to the negative 2, which is a perfectly good answer. Or if you prefer 1 over 25, that's fine too. And that's it for quiz 2.